Welcome to The Explainer. So today we're going to talk about a piece of tech that's, well, it's quietly supercharging our entire power grid. You could call it an unsung hero, and honestly, without it, our whole green energy future, pretty much dead on arrival. All right, take a look at these. These are what we call battery energy storage systems, or BESS for short. I mean, just think of them as giant rechargeable batteries, but for the entire grid. They're absolutely essential for making green energy work, storing all that power from solar and wind. But, and this is a big but, these powerhouses are facing a huge, totally invisible threat. So what is this big threat? Well, it's not what you might think. We're not talking about a software bug or some kind of physical attack. Nope, it's something much more fundamental. It's an enemy that's literally born inside every single one of those battery cells. Okay, let's get into the nitty-gritty. The problem is heat. Simple as that. See, every single time these massive batteries charge up or release their energy, they generate a ton of heat. And when you cram thousands, literally thousands of these cells together in one box, well, you've got yourself a major, major heat problem. And we're not just talking about it feeling a little warm. Unmanaged heat is a real triple threat. First, it just wrecks the battery's internal chemistry, which means it doesn't last as long. Second, it tanks the performance, so you get less energy out. And third, and this is the big one, it's a huge safety risk. It can set off a really, really dangerous chain reaction. Yeah, that chain reaction, it actually has a name. It's called thermal runaway. And it's basically a vicious cycle, right? The temperature goes up, which makes it go up even more, and it just keeps going, potentially leading to fires and total system failure. So you can imagine, stopping this from ever happening is priority number one for every single battery engineer out there. So for a long time, the solution was, well, kind of basic. Just blow a whole lot of air on it. Seriously. The industry was basically using these giant, souped-up HVAC systems, like a massive air conditioner, to try and keep everything from melting down. But here's the thing. As the batteries got more and more powerful, and as we started packing them in tighter and tighter, that whole brute force air approach just couldn't keep up. Air, it turns out, is pretty durable at moving heat around. So these systems were super inefficient, they were affected by the weather outside, they were incredibly loud, and they took up a ridiculous amount of space. They basically hit a wall. So it was clear the industry needed something way smarter, way more elegant. And that breakthrough, it came in the form of liquid cooling. And trust me, this technology has been a total game changer for energy storage. Now, the best way to picture how this works is to think of it like a high-tech circulatory system for the whole battery farm. Instead of just, blowing air on the outside shell, this system gets right to the heart of the problem and pulls that heat directly away from the source. And here, you can get a really good look at it up close. See that? There's a special coolant. It's usually a mix of water and glycol, and it's constantly circulating through these tiny little channels inside what are called cold plates. These plates sit right up against the battery cells, just sucking the heat away with unbelievable efficiency. The whole thing is actually a pretty elegant closed-loop system. It works like this. First, those cold plates grab the heat straight from the battery cells. Then, pumps push that now warm coolant over to a heat exchanger, which is basically just a radiator, and that's where the heat gets safely kicked out of the system. Then, the newly chilled liquid just gets sent right back to do it all over again. Okay, so all this sounds cool in theory, right? But what does it actually do in the real world? Well, the results are pretty dramatic. Let's break down the 4 key benefits that show you exactly why liquid cooling is the new king of the hill. First up, and this is a big one, way better heat dissipation. We're talking about keeping the temperature across an entire battery rack incredibly stable. Get this, there's less than a 3 degrees Celsius difference between the hottest and coldest spots, even when it's working flat out. That kind of uniformity is absolutely crucial for keeping the batteries healthy and making them last a long, long time. Benefit number 2, incredible scalability. Because liquid cooling is so darn efficient, you can pack the battery cells way closer together. This lets companies like Lithium, for example, achieve record-breaking energy density. We're talking about cramming 6.25 megawatt hours of juice into a single standard shipping container. I mean, that's enough to power over 2,000 homes for an hour. It's just way more power in way less space. Third, you get a huge drop in the amount of energy the cooling system itself uses. Think about it. That cooling system has to be powered by something, right? It's a bit of an energy parasite. But liquid cooling is just so much more efficient than the old air-cooled systems. It wastes a whole lot less energy just to keep things from overheating. How much less? We're talking about a 30% drop in that wasted energy. And what that means is that more of the precious stored energy actually gets sent out to the grid instead of being used up just to run a bunch of fans. That's a huge boost to the whole system's efficiency. And finally, we get to what might be the most important benefit of all, safety. I mean, the real question is, what happens if one of those thousands of cells does fail? Well, check out this quote from the really tough UL 9540A safety test. It shows that with modern liquid cooling, that failure is completely contained. The system stops the heat from spreading to its neighbors, effectively shutting down a thermal runaway event before it even has a chance to start. That's huge. Okay, let's zoom out for our final section and connect all these dots, because this is where it gets really interesting. This isn't just some story about clever engineering. No, this is about enabling a massive, fundamental shift in how we power our entire planet. You see, this one innovation creates this huge ripple effect. Cooler batteries, they're safer and last longer. That's a win-win. Denser systems, that means a smaller environmental footprint, right? We need less land for these energy farms. But here's the real kicker. When energy storage is this efficient and reliable, it makes renewables like solar and wind truly dependable. And that is what puts the accelerator to the floor on our transition away from fossil fuels. And this just perfectly illustrates a really powerful idea, doesn't it? Sometimes the biggest, most profound changes come from solving a simple, fundamental problem, but in a totally new and elegant way. Liquid cooling solved the battery's heat problem, and by doing that, it helped unlock the entire future of clean energy. It really makes you wonder, right? What's the next invisible innovation that's out there, just waiting to change our world?